Hey everybody, this has been coming back at you with another video here. Doing a little bit more CNC design today. So today what I'm going to be going over is stair treads in Vcarve Pro and cutting returns on stair treads. And this is something that I kind of had to figure out, for the place I was working at. But if anybody's ever made a stair tread with a return, and they've either done it on the table saw, or maybe you've taken your pieces and you've glued them on the end, or however you've done them, you know how difficult they can be to do. Um, I'll just kind of go over, a way to make this easier if you've got a CNC machine. So, um, the type of stair tread that I'm going to be doing here today is going to be an 11.5-inch box tread. So the first thing that I did to get this set up is I went and I made a square, and I set it to 11.5 by 48. Since we already have that done, then I went on ahead and came in here and did the return profile. Okay, so what I did here is I took handy dandy measuring tool and I measured off from the bottom 1.25 inches, and as you can see, if you look at the distance that I have between my points, they're both 1.25 inches there. So your standard tread, obviously your return is going to be 1.25 inches away from the piece, and generally it's going to be hanging off here just about a little bit, usually, was the situation you have. Now, for those of you that have never done this before, and maybe have been thinking about it, obviously this picture here is just showing like a square, as if it was square inside this little thing here. If you've already routed the bull nose on it, at this point you're good to go. As a matter of fact, I'd always recommend that you would put the bull nose on it. That way it just helps in the next step in manufacturing, and then the bull nose also would be on this end too, that you're going to glue these up, however, whether you're going to nail it, use screws or use clamps, or however you're going to get it together. So this array that you see all around here is a fixture that I have figured out and has worked really good. So what I've done is I've come off 1 inch away from here. So this is like a 1-inch piece of wood, and all this is to kind of hold this tread in place, and you can just use screws to hold that down. And a really neat trick, so obviously in this little video here, just to get everything right, what you would want to do is you'd want to come in here. I'm going to cut these vectors. And just kind of show exactly what we got going on here. So what you'll do is that'll represent your 1-inch block that's coming off there. Now I cut that vector to kind of do this. What you'll want to do is you'll want to square this up so that the jig that we're going to make here is going to be exactly right. So just when it cuts it, it'll get it perfectly square. So that'll be like the first thing that you want to do. So obviously I also didn't go over too. So like underneath this basically is going to be, some wood. You can use plywood, and you would fasten 2 boards on here to act as a way to hold this stair tread down. It's just a fixture that will help you do these, and where you can get them in really fast. Alright, so your next 1-inch piece of wood you can stick on the other side. With that one, it is not of tantamount importance if it's milled, because you don't really have to worry about it being accurate on that side. And what you'll see right here is this block is basically just a piece of scrap wood that you'll put in here to cut this tread to get it ready for the return. And what you do is you stick it right here. So what's going to be happening is, and this needs to come out here a little bit to exceed that. What's going to happen is where you see this line right here, this is going to be where that cutter, the knife or the router bit is going to be cutting that return. And you want to have a piece of scrap here, because if you don't have that piece of scrap there, what's going to happen is you're going to get tear out right here really bad. And you don't want that. So this way here has been the best way. And then if you notice, I've got here, listed some threaded inserts. And basically what you do is you put a threaded insert in here. In my case, I've used like a 1/4 inch threaded insert, and also did the same thing for the top and bottom. With this top one, these two top ones, what you're going to want to do is just take like a little shim and put underneath there. And what it'll do is it'll just protect the wood, keep it from being marred up by the bolt. And then you just tighten the bolts down with a ratchet, and that will hold that board down so that when it's machined, it'll stay in place. So the next thing is too, so when you're doing these treads, you'll notice that my profile cut right here is 2 separate cuts, and there's a reason why they're separate cuts. What I noticed, see, when I first started doing these, I did them with this profile and had them going all the way across. And what'll happen is, if you've got something, particularly, it'll usually happen when you have made 10 and you need all 10 of your treads, and they're made out of walnut or something expensive. When this cutter, if you let's say that if you had it and the cutter was going in this direction and went all the way through, it would take and actually tear this piece up. It would just tear it right out. So I did this cut here first to kind of help stop some of that. So what you do is you just set up your profile toolpath. Now what's cool is you can actually use a 1/2 inch cutter to do these. And when you do it, let's see, I do believe it's the inside cut that we want to have this happen on. And let's see, the inside cut, you can get away with doing, I've done these with a depth of 0.2 and had really good results. And let's see, what have I done these at? I think 150 to 175. I want to say 175 IPM, I think, is what I've done these in the past. And we just calculate that out. And then we'll go on ahead. So right here, as you can see, the cutter starts here and cuts in that direction, and we don't want that. So in order to combat that, we change the cut. Let's see, and now it's going on the outside profile. We don't want that either. Okay, there we go. So now, so what I did there is when I started this point, this angle here for the return, the angle is off. Well, the start point rather was here in the beginning. So what we had to do is we had to change that start point and make this start point right here. So as you can see, it's grayed out there, but what this will do is it'll cause that cutter to come over here and it will cut into the piece. So therefore it eliminates the risk of that piece being torn out. And if you're the person doing these treads, if your tread is a square tread and you haven't got the bull nose on it, it'll work a whole lot better. Meaning you won't really have to worry about the tear out as much as you would if the bull nose was already on it. But doing it this way, if you got the bull nose on it, you won't run into any problems. And let's see, then from there you can just have it cut this piece here, and what you'll do is you'll just use your cutter and make a calculation for that. And as you can see, you want to just double check it when you do it so it's on the right position. So what we're going to do is we're going to correct that. And as you can see, now it's the right way. So when you preview your tool paths, we're just going to go ahead and delete that first one for now because we don't really need it to kind of display everything. If you notice, preview that we have in place here, that what it's done is it's cut this pattern into here. As you can notice, I mean, this is the profile cut. So just, to explain the next part in the process. If we can get this thing to zoom in properly, it would help. But if you notice that you've got this curve right here, and this curve right here obviously is from the router bit itself. So when you're doing your return pieces, what you can do is you can take and cut these on the miter saw is the easiest way to do it, and it's got a 45 in it. And to get rid of that, all you need to do is go to a spindle sander, or I mean you could use a hand plane also, but the spindle sander probably be a little bit easier, and just smooth that out so that when you go to glue it to your tread, it'll fit in there, and it'll fit in there like a glove. And this is like one part to do it, just kind of a easy way to do it. Another thing I didn't really go over too is like this part where this tread sits in here. Easiest thing to do is just, if you can picture it, like that part of the tread will be sitting like in air, and what'll happen is, ideally in an ideal world, this this thing would drop right down onto the table, but generally speaking that's not what happens. It'll just kind of fall right there. Important thing to keep in mind is these returns, when they're being cut, have a tendency to get thrown by the router. So it's not something to be alarmed about. I haven't really had an issue with it breaking bits or anything like that, but it will break a bit if you've got a smaller 1/4 inch bit. You might run into problems. Time expectancy to do this, you're probably looking at about, oh gosh, I want to say a minute a tread, I think, for each return. And that's just what I've gone over here is just with like a left hand return, or a right hand return. But you can also do double returns with these. When you do a double return with this, just make sure that whatever your distance is. So like what you could do is, if you know where this thing is cutting out at, usually to leave like some sort of line or something from where your cutter has gone in there. and made that cut into your jig. And you'll be able to see where to put that at so it works out. I'll be the first to say that a lot of the times it's really scary doing double returns on this thing just because you're under the pressure to get them right. But there's that. So now I want to go over that's kind of like the first part of the basic technique, and using the setup that I've got here is just if anybody is doing it, it's not too complex for that shop to do. Now another thing I also didn't go over, which I need to go over, when I set the size and position of this table, I set it to 48 by 48, and that's the machine that I'm generally used to using. And this is just like a XY gantry where the table stays flat. But when I did this, I set the XY position to the 0 corner position, and on the machine that I'm used to using, like right here is the 0 where that red mark is. That's the corner of the machine. So like with the Laguna Swift, when you cut that machine on and you home it, that like you're supposed to when you cut it on, that is going to be the home position. So you can set this up there as your 0. And what that'll allow you to do is it'll allow you to use this jig and set it up quickly. So, and going over another thing before I go on to the more advanced part, like something that you can do that'll really make your life a lot easier if you're wanting to use this, is you can set up some index pins on this thing, and you can put them at 4 points. I mean, you could probably even get away with just doing 2, but we're gonna just do 4 since I'm the one making the video. And just set them there. And what you would do is you would machine these in to the table, and then you would machine this into the jig, and this way the next time you would go to use that, you would just get whatever pins that fit the holes that you're using. So if you've got a 1/4 inch dowel, you could machine a 1/4 inch hole, and it would put this jig exactly where it needed to be every single time. And your setup would be very, very fast. Now, another thing to keep in mind here is some of y'all, if you're used to dealing with different origin points, maybe you're used to doing something like this, and making an X on the table, like this, and let's see, let's do another line here, and doing something like this. You're like a Laguna Swift is a good example. Like it can hold 9 origin points in its memory there. So if you have different things you're setting up, that what I'm saying is, if you're switching origins a lot, or you're always constantly redoing them based on the size of the board, maybe your shop that does a lot of that, and the one I worked at certainly was, you'll need to center in on that position. You could do that this way, but I wouldn't suggest doing it. Like, I mean, obviously this thing is set up 48 by 48, but you could get a smaller deal, and you could just have this the return profile and make that cut with a smaller deal. But getting back to this and zeroing it out, if you make sure you're on absolute positioning, and if you don't know what I'm talking about, your CNC machine will have coordinate positioning, and you have save zeros, which are what you base it off of if you're doing multiple origins, or what the machine sees as 0, and those are the home switches. I would always suggest using absolute positioning to get this thing right. So if your absolute position is 0 0, that's awesome, great. Sometimes it's not, so if you set up a 0 and you go on ahead and run this, let's say you did have the 0 as way up out here, and let's say you could figure out what the absolute positioning is, and I would write that absolute positioning somewhere on the jig so you know what it is, so the next time you go to set it up, you don't have to sit here and try to get that point right there, because it's just enough to frustrate you, because the next time you go to use it, you'll have to be moving a little to the right and a little to the left. And that's another thing to mention too. If this tread does not come out right the first time, you can move your zero over to the left or the right and get it to until where that tread fits perfectly, which is something you're probably going to have to do. The first time I did this profile did not come out right, and believe me, it was kind of frustrating until I learned that trick. So now, the next step of this is, maybe you're in a shop that's got a vacuum hold down system, and you don't need this, but what if you're in a shop that does not have a vacuum hold down system? We're going to go over really quickly how you could do that. So the idea behind a vacuum system, and let's see if we can find a way to do this really quickly. Alright, so so the idea is you got this tread here, and you need some squares. We're going to make these 1-inch squares. And what we're going to do is we are going to make sure that we have like a 1/4 inch between each of these. So what I just did was an array copy, and if you guys don't know how to use this feature, it is an awesome feature, and we're just going to go over really quickly how to do that, and we're probably going to have 24. Okay, that went too far. We're just going to make these 1/4 inch. Alright, we got it going the wrong way. I'm going to do... Oh wow, check that out. So basically what this has done here is this is just given like a vacuum channel for all these to fit in. And we could even we could leave it like that, but we're just going to make sure that we get this right here. Let's see. So that's about 0.25. All right, great. And let's come over here. So what you could do that, and then like the next thing that you could do is in our case, we're going to be using a 1/2 inch cutter. What you're going to want to do is you're going to want to make sure that there's some sort of way to hold this down. So for a lot of people that are going to be doing stair treads, they're not going to have, you're probably going to have more space. You know, this thing's going to be sticking out a little bit, more than likely. You're probably going to have 3 or 4 extra inches. And in an ideal world, if you can creep it up right close to here, that'll be cool. But you're probably going to have a situation that's more like this, where I put this box out and you got this little bit of extra excess because just give yourself some room. So what we're going to do is we are going to make something that simulates if that was there. So whenever you're doing a vacuum hold down jig too, and particularly something that is going to be like what we got here, you want to make sure that it's not reaching the cutter. Well, even what we have here is fine too. So, because if it reaches the cutter, you know, it's not going to work. It'll cut into the gasket and then it'll, you know, not allow you to have the intended result. So and we're just going to use node edit mode and bring this back into place, and we're going to join these vectors. Now they should all be one piece. So, and then from here, you know, we can do the same thing that we just did, and put some squares in here. And you know what? Let's do, we'll do 0.75, 0.75. We're going to use our offset tool, and we need 1 row and 8 columns. We'll probably just do it, and that'll get it. So we got that, and that'll do our channel. And then what we probably also need to do with this one is just have it, I don't want that big of a gap, so if we had something like this that's stuck in there, we're going to make that about 1/4 of an inch. I mean, the idea is that this here will be 1/4 of an inch. I'm not going to get it exactly right for this video, but then the next thing that you would want going on is a entry point for your, and what this here represents is, this just represents just a hole that you would put in this, and you would just drill through it with a drill bit, and you would do the same thing up here for this point, and just have some sort of gasket, you know, that would run all the way around it, so it would hold vacuum. So if you wanted to make a vacuum pump, that's how you would do it. But yeah, running the treads, that's a way that you can do them. You know, I hope that this helps out. I mean, I didn't see anything on YouTube in revolving stair treads, and nobody really shown you much of how to come up with a good way to do them. And yeah, this is just what I got for this video. If anybody has any more questions about anything or has a suggestion for a different project, just let me know. Thank you.